So hello everybody, my name is Matej and I'm working at the University of Ljubljana, and today's presentation will be about 3D printing. So here is a summary of today's presentation. First we will look how 3D printing works, then we will see what types of 3D printers are available on the market. We will see which kind of materials you can print with a 3D printer. Then we will look at the supports, 3D printing supports. This is very important when you do 3D printing. Then we will check what are the advantages and disadvantages of the 3D printing compared to the traditional manufacturing methods. And then we will check the HOP do-it-yourself harvester, how we use 3D printing to create the harvester. Okay, so how 3D printing works? So 3D printing is a technology that creates three-dimensional object from a digital model. So first we need to have a digital model in order to create a 3D printed model. So here you can see the digital model of the do-it-yourself generator rotor. And to create that model, you first need to know how to use a design so 3D designing software like AutoCAD or SolidWorks. So after we have designed a digital model, we need to slice the model. So we need to have additional software which slices the model. So what that means, slicer is slicing the digital model into separate layers. When we sliced the model, we can then upload the sliced model to the printer, and printer can print the model. So how 3D printer works? 3D printer works by building the object layer by layer. So it builds the first layer, then second, third, until the finished product object is built. That kind of building process allows us to create object that would be very hard or unable to create using the traditional manufacturing methods like sewing, 3D CNC cutting, and so on. So what types of 3D printers are available on the market? So there are several 3D printers available on the market, each using different technology to build the objects. So the most common 3D printers are called FDM, or Fused Deposition Modeling. FDM printers work by extruding the thermoplastic through a heated nozzle. So the nozzle moves on a predetermined route, depositing the material and builds the object layer by layer. So here is a video of the time-lapse of the building. So here's the time-lapse of building the 3D object of the HOP harvester rotor. So the second printer is SLA. It's called stereolithography. So this printer uses photopolymer resin and the laser. So the laser traces each layer of the object in the photopolymer resin and then solidifies the object. The build perform moves a little bit up, and the process repeats for the next layer. Then we have the SLM printer, or selective laser melting. With this printer you can print the objects from the metals. It uses high-powered laser and selectively melts the layers of metal powder. So when all parts of that layer are melted, it adds another layer of powder, and the process is then repeated. So with a 3D printer you can print or use a lot of materials. The most common ones is plastic. So we have a PLA. PLA is plastic. It can be printed quite easily, but the problem is that it is not able to withstand high temperature. So it's good to about 50-60 degrees Celsius. On the other side, we have ABS. ABS is a little bit harder to print, but it can withstand higher temperatures, for example, up to 100 degrees Celsius. And we are also using the PET. PET is also quite easy to print, but it can also withstand higher temperatures like ABS. We can also print metals. We can print titanium, aluminum, stainless steel, but the printers that can print metals are relatively expensive. Here is, for example, the picture of the printed parts from the plastics. Here is an example from metal, object constructed from metal. And we also have a ceramics. If you want to have a product which has high heat resistance and durability, you can also build it from the ceramics. Okay. So one more important thing when you 3D print are supports. If you have an object, if you want to print an object with a large overhangs, you need to add supports to prevent object from falling down. So the general rule is that you need to use supports if the object has overhangs more than 45 degrees. Here is a time lapse of some printed object. Maybe you can show the next one, it would be better. So yes, about this support, here you can see the object is here and the supports are here. So these supports are normally automatically added by the slicer, but you can manually adjust the density, pattern, placement. You can also print if you print the object and see that some parts are not good, you can manually adjust the supports or manually add support to some places and repeat the process to see if the object is repeat the 3D print to see if the supports are helping to achieve better product. So here you can see the finished 3D object. This part has overhang which is quite low, so it can print without supports, and these parts need supports to be printed correctly. It's also possible to use soluble supports. So if you have more advanced printer with dual extrusion head, you can also use supports that can be soluble in water. That has one big benefit. After you finish printing, you can put this object into the water, and the support material can be removed by itself by the water. So now we came to the advantages of 3D printing. First advantage is customization. So 3D printing allows us to create very customized product. So this is particularly beneficial in consumer product when unique designs are desired. So one of the significant advantage of 3D printing is speed. 3D printers has the ability to produce object very quickly. So if you see that the object is not good enough, you can redraw it, put it on the 3D printer, the upgraded version to the 3D printer, and in a few hours you have the like finished prototype of or upgraded object. So if you want to build a small product with a small number of items, you can also think, or how to say, you can also check if the 3D printer is okay for you. So you can use 3D printer to build finished products if the production runs are small. So as we already said, with the 3D printer you can print very complex geometries, and that kind of geometries or objects would be unable or very hard to build using the traditional methods. Okay. So 3D printing has also a lot of challenges. First is limited material option. Each year the materials you can print is, the material list you can print is bigger, but still some materials you cannot print. For example, such material is wood. There is also problem if you want to build a big object with very high accuracy. In our lab, I think the longest print took around 75 hours. So here you can see the H-Hope do-it-yourself generator rotor, and after you print the object, you need to clean these holes, you need to remove the supports. So you need some kind of post-processing to achieve the desired finish of the product. And even if you use the same printer, the same material for two objects, the object can have some differences. So it's quite a challenge to use 3D printing when you need high quality critical applications. Okay, so this is the H-Hope do-it-yourself harvester. So this harvester will be designed to be easily manufactured using readily available methods on the market. It will also include several plastic parts that can be produced using the 3D printer technology. We will create data and knowledge hub, which will be available in GitHub. And on this data and knowledge hub, there will be instructions on how to use a 3D printer and how to print plastic parts for the do-it-yourself harvester. It will also have 3D models of the plastic parts that will be needed to assemble the H-Hope do-it-yourself harvester. So thank you for your attention.